You've got no time left. Nice. Let's get that. All right, so we're gonna check. We're gonna see how we did with this. So sine of theta equal 1/2. We want to determine what our angle could be from the crowd. Any ideas? Giselle, what'd you get? 30 degrees. Let's take a look over here at 30 degrees. Y is equal to 1/2, so that would be an angle that works. If you wrote it in radians, I will take pi over 6. You're going to notice today, most of my answers are going to be in radians here in a second, because I find those to be harder for us to remember, and so I'm going to practice the kind of like hard version. And did anyone find any other angles? Sadie? 150 degrees. Also, sine would be positive, and so that one is also going to work, and that would be 5 pi over 6. In the third and fourth quadrant, sine is now going to be negative, and so you're not going to find any angles down there. So we have 2 answers for theta for that one. Okay? All right, next up. Cosine of theta equal to negative root 3 over 2. As you're looking, I know some of us are just looking at our unit circle, but the goal today too, the more we see these, is going to be to kind of also think about it. So when you see cosine is negative, you should be thinking, I know that's going to be true in 2 quadrants. So be trying to picture or then look up in quadrant 2 and 3 where cosine is negative root 3 over 2. And Deanthea, what'd you get?
150.
150. Did you find any others?
210.
And 210. 150 and 210. And in radians, that would be 5 pi over 6 and 7 pi over 6. These 2 right here. Boom, boom. Cool? Okay. And last but not least, tangent. Tangent is not x or y, but how do we find tangent? We divide y over x, and so it takes a little bit more work, but I gave you one that's not too bad. If it's 1, raise your hand. Does anyone remember which of these x's and y's, when we divide y divided by x, we're going to get 1? Where is that going to happen? How in the world are we going to get 1? Okay, hint. When I have a number divided by itself, like what's 5 divided by 5? 1. So does anyone see anywhere where your y and your x are the same? Pi over 4 or 45 degrees. You have root 2 over 2 divided by root 2 over 2. That's going to cancel out or give you 1. Okay? So we're at pi over 4. And then I heard Lazaro say 5 pi over 4 because that is the only other place where it's going to be positive, because both of these are negative, and a negative divided by a negative is positive. In degrees, that's 45 and 225. Cool? Okay, so what we are doing right here is we are actually solving a trig equation. Right? This is trig, and it's equation because I have an equal sign, and we're solving it because we're solving for what's unknown, which is theta. The second part of this unit is called solving trig equations. The first part was verifying or proving trig equations. That's what you've done all the last 3 or 4 days. Now we're going to be solving trig equations. So our goal is going to be to get something that looks like this, a nice basic trig equation, so that we can write down our values of our angles. We're going to see some that are a little more complicated that we got to do some work to get it to look like this, and then we're going to write our answer. Okay, so let's look at our first example. We're going to do 2 examples together, and then y'all are going to do 2 practice problems, and since it's a Wednesday, we'll be out of here. Your problem set is due on Monday. Tomorrow I have tutorials, and or find me lunch on Friday if you have questions on that. On Friday, you're going to have your first mini quiz to see where you're at with this stuff. So here's what your quiz will look like. The beginning of class, you're not going to come here and just start. It's shorter than a typical one. We're going to come in here and kind of wrap up the solving stuff that we're going to be doing today and tomorrow. And then you'll have like the last 25 or so minutes to complete your quiz. It's going to be 2 multiple choice and 2 free response. So the 2 multiple choice, one of them is going to be kind of based off of like the proving stuff that y'all did over the last 3 days. One of them is going to be over the solving stuff we're doing today. Okay? For your response, same thing. One of them is going to be proving stuff, doing a proof by hand, like we've done the last few days. One of them is going to be on the solving stuff we're doing today, tomorrow, and the beginning of Friday. Okay? So that's the layout of that quiz so you know what to expect. Alright, so let's jump into an example. We've got solve 5 cosine x minus 3 equals cosine x minus 1 on the interval 0 to 2 pi. So when I look at that, this is not, it does not say prove or verify. We're not taking one side and trying to rearrange to get the other like we've done the other days. What we want is we want to solve for the unknown. We want to know what this x is, what angle would make these two sides equal. Okay? So we want to solve for x, we want to eventually get x by itself. And the way we're going to do that is to try, because I see cosines here, to get all the cosines together and get something like we saw in our do first, cosine equals some number, and then we're going to look it up on our unit circle. Okay? So let's do some solving. We've got 5 cosines over here. We've got 1 cosine over here. Those are like terms, just like 5x and x. We can move them together. I can subtract a cosine x from this side and subtract it on the other side. And if I had 5 cosine x and I subtract 1 cosine x, I now have 4 cosine x minus 3 equals, on this side I'm left with just negative 1 if I subtract the cosine. Okay? We're getting closer because I now just have cosine, one of them, I don't have 2 of them. Now that I have it over here, I want to isolate cosine, I want to get it by itself. So I'm going to start moving all my numbers over to the other side. So I'm going to add 3. And I have 4 cosine x equals negative 1 plus 3 would be positive 2. Lovely. And then, Kevin, what can I do to get rid of this 4 right here? Divide by 4, we're just doing algebra, so it's just going to be the same way as if we were solving for a variable. And we have cosine of x equals 2/4, or that simplifies to 1/2. And notice we should end up with all these problems with something that looks a lot like what we saw in the do first. And then we can go ahead and find the values of x by thinking of where cosine is 1/2. So don't look at it. Don't look at your unit circle. Don't look at your unit circle. Because you're going to notice, I think today it's been funny, because after I've had like, the last 3 days have been pretty hard in class. I feel like you're like, proofs. And so today we're back to more like a normal pre-cal lesson that everyone today has been like, man, that's all, like this isn't that bad. So this, I agree, hopefully you don't feel like that's as hard as we've been doing with proofs and stuff. But the hard part is, if you don't have your unit circle on your quiz or your test, finding these answers means you need to know where cosine is 1/2. So I want you to kind of challenge yourself today, because these problems are going to go really fast, to pause before you just look, and let's think, just in the first quadrant, maybe for today, if we need to kind of remember. If you think about our 3 angles, I'm going to think it's definitely not the middle one, right? Because that's the root 2 over 2, root 2 over 2. We should feel comfortable with that. This one is the one where x and y are opposites. So which one has x equal to 1/2? Is it the 30 degrees or the 60?
60.
The 60. So try to start thinking through. You might not be able to get all the angles, but at least maybe try to figure out which one in the first quadrant. I'm going to write pi over 6 rather than 60 degrees. No, sorry, pi over 3. Instead of 60 degrees, because this says between 0 and 2 pi, which is a full circle, but that's in radians. And so I'm going to give my answer in radians. I know that there's an equivalent degree answer of 60 degrees, but I'm going to follow whatever they have up there. So that's pi over 3. If I have the full circle, though, I know that it's also going to be 1/2 down here. So the tough part is remembering what that angle is. So the way I would think about it is how we learned this, which was like counting out the pi over 3's in fractions. So if this is pi over 3, this would be 2 pi over 3. 3 pi over 3 is going to be pi, which we know is here, right? 4 pi over 3 would be in this quadrant, which means we're going to be at 5 pi over 3. So you can look them up, but also start quizzing yourself to kind of see what you can figure out using just your brain. Cool?
Okay.
Pi over 3 and 5 pi over 3 is where cosine is 1/2. Alright. One more together, and then y'all are going to practice 2 with your neighbors. It says solve 2 tan minus root 3 equals tan on the interval 0 to pi. So this time, you're not looking all the way around the circle. Which quadrants are we looking at? 1 and 2 only. Okay, so just keep that in mind when you go with your final answer to find the quadrants. So we're only looking at quadrants 1 and 2. Let's go ahead and rearrange. So this time, now that you've seen 1, I'm going to have y'all kind of help me out. Let's see. Jonathan, what do you think you're going to do first? What would you move to try to get tan by itself? Okay. So you can do this in a couple different orders, but he says let's take away 1 tangent from this side and that side. 2 tangent minus 1 tangent would be just 1 tangent. Minus root 3 equals, if you do tangent minus tangent, you're left with 0 on that side. And then I would just, I'm really close to getting tangent by itself, just add root 3 over to the other side. And you have that tan x is equal to positive square root of 3. So then we want now to find our x values, our angles, that would make this true. Not as easy as tangent equal to 1, because that's where we know x and y are the same, which means it's got to be this one 30 degrees or this one 60 degrees, and then we're going to see if there's any others in the other quadrants. Okay? And at that point you just got to like divide y over x for one of these and check and see which one works. So, any takers? Anyone going to give it a shot? A wild guess, and then we'll divide and see if you're right. 30 or 60? Who wants to try 30? Who wants to try 60? No one voted. Thanks, Kevin. You want to try 60? Alright, we'll try Kevin. Kevin's with me. Let's try 60. If I do y over x, I've got root 3 over 2, because that's my y, divided by my x 1/2. Yep, y'all have done a lot of this now. Times 2 over 1. Your 2's cancel. Root 3 over 1. Kevin, you're right! So, it doesn't mean like you have to pick the right one first. It just means you got to start trying them because it's hard to tell which one's going to be root 3. So that means we know 60 degrees or pi over 3 is going to be one of our angles, or maybe the only angle. So let's take a look. We are only going to pi, which means if we look in the second quadrant, the only place where y is root 3 over 2 and x is like 1/2 is right here at 2 pi over 3, but x is negative 1/2. If I put a negative on the bottom right here, this whole thing would become negative, and that's not going to work. So that is going to be our only angle for this one. So it is possible for you to have one angle. It's possible for you to have 2 angles. You'll see later it's going to be possible for you to have even more than 2 angles and all sorts of good things. Okay? Alright, so y'all flip the page. You're going to practice. There are 2 problems here for you to try. They should go pretty quickly, so take the time to try to figure out the angles without just looking them up on your unit circle. But then you can go ahead and finish them off. We're going to come back and talk in our last 10 minutes about a few other cases and things on your problem set before we get out of here. I'm going to catch up on giving out some signatures. Go use some. Perfect. So want to know what a y is root 2 over 2. So thinking about your unit circle. The second one, which is the middle one, or the second one. The middle one or the second one is.
Stop looking at the unit circle.
Okay. I mean, you're going to look at all 4 of them, but the only ones where sine is going to be positive are going to be the top 2. And it's the one in the middle, so 45 degrees or pi over 4. And then find the one in the second one. So it wouldn't be 2 pi over 4, because that simplifies to pi over 2, right? Pi over 4 is good. So if you're picturing your unit circle, yeah, that's pi over 4. We know sine is also going to be positive in the second quadrant, so we're also looking for whatever's in the middle right here. And if we don't want to look it up, 2 pi over 4, it's going to be 2 pi over 4, because 2 pi over 4 is up at the top. That simplifies to pi over 2, right? So it's not 2 pi over 4, it's not 2 pi over 4, so it's going to be 3 pi over 4, because that doesn't simplify. And look at your unit circle. But 3 pi over 4.
Wait.
Anyone I owe signatures to that answered questions? Do I owe anyone signatures that answered questions?
You're fine, dude.
Did you got the first one?
Yeah.
What's the second?
And 3 pi over 4.
Yeah.
3 pi over 4.
I don't know.
Do you see why, Jonah?
Yes, how many are there? What? I do not have No.
Okay, so then like when you're trying to remember this one, it's also going to be over 6, right? That's why I'm Good, awesome. Okay, I'm gonna give you another minute or 2 of your done. Hang tight, because we're gonna check them and I'm gonna add on a few things. Someone's asking about something for yours here. Did you find your mistake? Yeah. And then you're going to need to study that by Friday, or you're going to get to this point on a free response, you can rush credit, but on a multiple choice, you're going to have to have a bunch of things but then you're in the second quadrant. It's also root 2 over 2 here at 3 pi over 4. Okay? Alright. Voices up, ice back up here. I'm going to pick some popsicle sticks for some people to share their answers. Okay, first up, 1. The one right here, what'd you get for your x values? Where'd you get to?
I got to where I had sine over x with the square root 2 over 2.
Cool, awesome. Thanks for sharing. So you got sine x equals root 2 over 2, absolutely correct. And this is the point that I honestly think on the unit test and quiz, a lot of people are going to get to this point And then if we're not like studying or using our tools with our unit circle from unit 4, we honestly can't really go on from here, right? Because you're like, I don't know where that happens. So we need to be thinking through. Root 2 over 2 came from a 45, 45, 90 triangle. So that's always the time when you get root 2 over 2s, that's always going to be these ones that are splitting the quadrants in half, right? The like one in the middle. So that's going to be pi over 4, but then it's going to happen at another one somewhere from 0 to 2 pi. So sine is also positive, sine is y, so it's going to be positive above the x-axis. So we're also looking for the one in quadrant 2, which is going to be 3 pi over 4. Pi over 4 and 3 pi over 4. Got it? Okay, next up. Anyone, oh wait, I was going to pick something. Short term memory. Melanie. Oh, wow. What'd you get for this guy?
Okay. I got cosine x equals root 3 over
Cool. Cosine x equals root 3 over 2. And then, what'd you get for your x value?
I got pi over 6.
Cool. That works. If I go over here to pi over 6, I get root 3 over 2. We need to go all the way. Sorry, yours doesn't say this. I'm going to change the problem in a second to talk about it. Yours says from 0 to 2 pi, right? Which means we got to look now all the way around the circle. If you can get at least quadrant 1 today, you're in a good spot. But like by memory. But then if we keep looking around our unit circle, we know it's going to happen again in the 4th quadrant because that's also where cosine is positive, and that's going to be Messiah 11 pi over 6. So we have these two. Now, I want to spend our last bit of time talking about how these problems are going to get a little bit more difficult. So hopefully you felt like as you're practicing those that those are doable. Okay, if not, come talk to me and we can kind of like work through it. But the way that these problems are going to get slightly more challenging is in a few ways. So one way is I'm going to start to give you problems that don't just have cosine and cosine. They're going to have like cosine and sine. And there's some strategies we're going to learn tomorrow that are going to help us to like separate those into two things and still solve. Okay, so on your problem set, the last problem on the back, we haven't gotten there yet, but we've gotten to everything else. Because you're going to see the one on the back of the problem set on the very last problem has sines and cosines. Okay, so that's how it's going to get a little bit more difficult tomorrow. Also, another way it'll get more difficult, which I want to talk about now since we have some extra time, is they'll change the interval from just a full circle, 0 to 2 pi, to something crazy like this. So if you want to find some space on this problem and change it and kind of take some notes, let's pretend a little more abstract thinking that I asked for you to tell me all the x values on the interval -infinity to infinity, which means our angles are not bound by just 1 degree all the way to 360 degrees, right? If you recall, back in Unit 4, we talked about how every angle has infinitely many co-terminal angles. If I'm sitting here at pi over 6, or let's do degrees to make it a little more friendly for y'all. If I'm sitting here at 30 degrees, if I walk a full 360 degrees around, I'm going to end up back at 30 degrees, right? So when I'm at 390 degrees, 30 plus 360, I also have a cosine value of root 3 over 2. Agreed? So if I ask from -infinity to infinity, you can't just say pi over 6. You got to start adding full circles. And because you can't list infinitely many angles, what we're going to do is we can write an equation to represent any of the possible answers that are a full circle added on to pi over 6 or a full circle added on to 11 pi over 6. Okay? So here's how we would do something like that. So let's say this is our interval. We got these two as the locations within 0 to 2 pi. Now we just have to extend those to all of the other possibilities. So I'm going to write two little equations, one for pi over 6 and one for 11 pi over 6. One for pi over 6 and one for 11 pi over 6. Let's start with pi over 6. If I'm at pi over 6, or like we said, 30 degrees, I can add a full circle and I end up in the same spot, right? So let's add a full circle, which in radians is 2 pi. But I could do that once. That would be one time, right? Or I could do two 2 pi's, right? I could do 2 circles, or I could do 3 circles, or 4 circles. So I'm going to multiply 2 pi times a variable. For some reason, in textbooks, they like to use k. You could use n, you could use whatever. Where k is just an integer. So it's just like 1 or 2 or 3 or 4 or -1. That means that I'm adding 1 circle, or I'm adding, if this is a 2, 2 circles, or 3 circles, or so on and so on and so on. So this is an equation to represent all of the angles that are in the same place as pi over 6, and have cosine equal to √3/2. Okay, let's do it for 11 pi over 6. 11 pi over 6 plus any number of full circles, so 2 pi k. This would be the crazy, kind of more abstract version of writing our answer for all real numbers, negative infinity to infinity, not just 0 to 2 pi. Now, Julian, I think it was Julian in my second period, asked a good question that I liked. He was like, well, if I wrote it in degrees, he wanted to make sure he was understanding what was happening here. The equivalent of this in degrees would be, what's pi over 6? 30 degrees. And you would add a full circle is 360 degrees times k. So you can write it like that as well if you're writing it in degrees. Okay? Cool? Alright, so on your problem set, listen while you are getting ready to leave. On your problem set, you can now do the entire thing except for that last problem, because like I said, it's not just going to have cosine or sine, it's going to have a mix. We're going to talk about what to do with that tomorrow, okay? Cool?